The first thing you notice when you stand next to a BYD Seagull in a Shenzhen parking lot is how small it is. Not small in the way a hatchback is small, but small in a way that feels almost deliberate, almost philosophical, as though the engineers had asked themselves how little car a family really needs and then designed exactly to that boundary. It comes up to your hip. Its wheels look as if they belong on a slightly larger bicycle. The plastic of the bumpers is unembarrassed about being plastic. And yet, this car, or others closely related to it, are now being sold for the equivalent of around 10,000 US dollars, sometimes less, in markets that include China, Mexico, Brazil, Colombia, and parts of Southeast Asia. In 2 years, it has become one of the best-selling vehicles on Earth. Families buy them, young couples buy them, delivery drivers buy them, and quietly, in the background of this commercial success, a question has begun to gather weight among engineers, regulators, and crash test organizations across 3 continents. The question is not whether these cars are cheap. That much is obvious. The question is whether cheap, in the year we now live in, can still be safe enough to carry the people we love. To answer that honestly, you have to begin not with the car, but with the framework around it. Modern automotive safety is no longer a single number stamped on a brochure. It is a layered system of structural integrity, restraint design, electronic intervention, pedestrian protection, and increasingly, software. A vehicle that performs adequately in a frontal crash may collapse under a side impact. A car that protects an adult driver may fail a child in the rear seat. A model sold under one name in one country may be a structurally different vehicle when exported under the same badge to another. This last point matters more than most consumers realize, and it sits at the heart of the BYD safety conversation. The Seagull sold in China is not, in every meaningful sense, the same Seagull sold in Latin America under the name Dolphin Mini. The export version is built for different regulatory environments, different roads, different expectations, and sometimes different price points. When safety organizations test these cars, they are not testing one product. They are testing a family of products that share a silhouette but not always a soul. In late 2024, the independent crash testing organization Latin NCAP published results for the BYD Dolphin Mini that sent a small shock through the industry. The car received 0 stars for adult occupant protection. 3 stars were awarded for child occupant safety, a result that was neither catastrophic nor reassuring. The frontal impact revealed unstable structural behavior in the passenger compartment. The side impact showed marginal protection for the chest. The car lacked side curtain airbags as standard, a feature that has been considered baseline in European and North American markets for nearly 2 decades. Electronic stability control, another technology long regarded as essential, was not standard across all variants. The pedestrian protection score was modest. The advanced driver assistance systems were judged insufficient by the testing body's current criteria. None of this meant the car was a death trap in the colloquial sense. It meant something more specific and more troubling. It meant that the car, as configured for that market, did not meet the standard of protection that organizations like Latin NCAP believe a 2024 family vehicle should provide. The response from BYD was measured. The company pointed out accurately that the vehicle complied with the regulatory minimums of the markets in which it was sold. This is true. It is also the kind of truth that conceals as much as it reveals. Regulatory minimums in Latin America, in much of Southeast Asia, and in parts of Africa are calibrated to a different era of automotive engineering. They were written when seatbelts and a single airbag were considered sufficient. They have not, in many jurisdictions, been updated to reflect the consensus reached in Europe, Japan, Australia, and North America that side airbags, stability control, autonomous emergency braking, and reinforced occupant cells are no longer optional features but foundational ones. A car can therefore be perfectly legal and simultaneously fall short of what informed engineers would call modern. The gap between legal and modern is the territory in which the $10,000 electric car now lives. To understand how a car arrives at that price point, you have to look upstream into the supply chain that BYD has built over the last 15 years. The company is not, in the conventional sense, only a car maker. It began as a battery manufacturer, and it remains one of the largest in the world. It mines its own lithium. It refines its own cathode materials. It builds its own semiconductors. It manufactures its own electric motors, its own power electronics, its own seats, its own glass in some facilities. This vertical integration is the engine behind the price. When you buy a Seagull, you are buying a vehicle whose components have moved through a single corporate bloodstream from raw material to finished product. There are fewer middlemen, fewer markups, fewer logistical inefficiencies. The savings are real, and they are passed to the consumer. But vertical integration cuts both ways. When a company controls every layer of production, it also controls every decision about where to economize. A bracket can be made thinner, a weld can be shortened, a grade of steel can be substituted for a slightly less expensive one. None of these decisions, taken individually, would compromise safety. Taken together, across thousands of small choices, they shape the character of the vehicle that emerges at the end of the line. The Seagull's body is built around a structure BYD calls the E-Platform 3. The battery, a lithium iron phosphate unit known as the blade battery, is integrated into the floor in a way that adds rigidity to the chassis. This is genuinely clever engineering. Lithium iron phosphate chemistry is more thermally stable than the nickel manganese cobalt formulations used in many competing electric vehicles, and the blade format has performed well in penetration tests, resisting thermal runaway under conditions that have caused other batteries to ignite. In this respect, the Seagull is arguably safer than some considerably more expensive electric cars from earlier generations. The battery is unlikely to be the thing that hurts you. What might hurt you is the structure surrounding it under conditions the battery itself was never asked to address. A side impact at urban speed, a collision with a larger vehicle, which in many of the markets where the Seagull is sold is almost every other vehicle on the road, a rollover on a rural highway. These are the scenarios in which the engineering choices made to reach a $10,000 price point begin to express themselves. There is a tendency, when discussing inexpensive cars from emerging markets, to fall into one of two equally lazy positions. The first is reflexive dismissal. The car is cheap, therefore it is dangerous, therefore the people who buy it are either uninformed or reckless. This position ignores the reality that for hundreds of millions of families, the alternative to a cheap new car is not a more expensive new car. It is an older, less safe used vehicle, or a motorcycle, or no private transportation at all. The second lazy position is reflexive defense. The car meets local regulations, therefore criticism is a form of cultural condescension, therefore Western safety standards are simply protectionism in another costume. This position ignores the fact that physics does not negotiate. A B-pillar that buckles in a side impact does not buckle differently because it was manufactured in a country with different regulations. The question is not whether a Seagull is good enough relative to its price. The question is what good enough actually means when a child is sitting in the back seat. Engineers who have examined the Seagull and its export variants tend to converge on a more nuanced assessment than either of the lazy positions allows. The car is not, by the standards of contemporary engineering, a poorly built vehicle. Its panel gaps are reasonable. Its electrical systems are sophisticated. Its battery management is genuinely advanced. Its software, particularly in the most recent variants released in 2025 with BYD's God's Eye Driver Assistance Suite, is capable of features that would have been the province of luxury cars a decade ago. The criticism is not that BYD has built a bad car. The criticism is that the car, in its export configurations, omits specific protective elements that the global engineering consensus now considers necessary, and that the omissions are not visible to the average consumer. A buyer in Mexico City standing in a showroom sees a small, modern-looking electric car at a price that nothing else in the segment can match. They do not see the absence of the side curtain airbag. They do not see the simplified body in white. They do not see the reduced sensor suite. They see what they are meant to see, which is affordability and modernity, and they make the rational decision that follows from the information they have. This is where regulators, more than manufacturers, bear the deepest responsibility. The history of automotive safety in the 20th century is, almost without exception, a history of governments imposing standards that industry resisted on grounds of cost, and then, after the standards were imposed, complying with them and selling cars that were both safer and eventually no more expensive in real terms. Three-point seat belts, crumple zones, airbags, anti-lock brakes, electronic stability control. All of these were once described as luxuries that would price ordinary families out of the new car market. None of them did. Each became, in time, invisible, a baseline assumption, a feature you no longer have to think about. The reason a driver in Germany or Japan or Canada can buy a small, inexpensive car today and trust that it meets a high baseline of protection is not that manufacturers in those markets are more virtuous. It is that the regulatory floor is higher. When the floor rises, the entire industry rises with it. When the floor remains low, vehicles that would not be legal for sale in one country are not only legal but celebrated in another. The Seagull, then, is best understood not as a moral object but as a mirror. It reflects, with unusual clarity, the global asymmetry in how human life is valued by the systems that regulate the machines we entrust it to. A car that would require substantial structural modification to be sold in Europe is sold without modification in Brazil. A car that would need additional airbags to clear Australian standards is sold without them in Colombia. The price difference between these configurations is not enormous. Industry analysts who have studied the cost of bringing a vehicle like the Seagull up to modern safety standards estimate the additional manufacturing expense at somewhere between $400 and $800 per unit. This is not a trivial sum at the $10,000 price point. It is also not, in the broader context of a multi-decade ownership relationship between a family and a vehicle, an unreasonable one. The decision about who absorbs that cost, the manufacturer through reduced margins, the consumer through a slightly higher price, or the public through the ongoing toll of road fatalities, is fundamentally a political one, and it is being made in most of the markets where the Seagull is sold by default rather than by deliberation. There is a quieter question underneath the regulatory one, and it has to do with what families actually do with these cars once they own them. A vehicle that scores 3 stars in a controlled crash test is not the same vehicle once it has been driven for 5 years on poorly maintained roads, fitted with aftermarket parts of unknown provenance, and modified by owners who often have no formal training in automotive engineering. The Seagull, like most inexpensive cars, will spend much of its operational life outside the conditions in which it was tested. Its tires will wear unevenly, its suspension geometry will drift. Its battery, while robust, will degrade. Its software will or will not receive updates depending on whether the regional importer maintains the infrastructure to deliver them. Long-term safety is not only about how a car performs in its first year. It is about how the engineering choices made at the design stage age across the actual life of the vehicle in the actual conditions where it is driven. Here, the data is genuinely incomplete. The Seagull has not been on the road long enough to generate the kind of multi-year reliability and accident data that would allow a confident assessment. What we can say is that the architecture of the car, the depth of the battery integration, the simplicity of the drivetrain all suggest a vehicle that should age well mechanically. What we cannot say, yet, is whether the structural choices made to reach its price point will reveal weaknesses that controlled testing did not capture. To return, finally, to the family standing in the showroom, the honest answer to whether a $10,000 BYD compact car meets modern safety standards is that it depends on what you mean by modern and what you mean by standards and which version of the car you are actually being sold. In China, where regulatory pressure has tightened considerably and where BYD competes against domestic rivals with increasingly sophisticated safety packages, the latest Seagull variants are meaningfully better than the export models that have been tested in Latin America. In Europe, where BYD has chosen to homologate different vehicles for that market, the question does not really arise because the cars sold there are different cars. In the markets where the controversy actually lives, in Mexico and Brazil and Colombia and beyond, the truthful answer is that the car represents a significant improvement over the older used vehicles it replaces, a meaningful step backward from the small new cars sold in wealthier countries, and a genuine ethical question about whether the global automotive industry, having spent 50 years learning how to keep families alive in collisions, is willing to apply that knowledge uniformly or only where it is forced to. The Seagull is, in the end, neither hero nor villain. It is a symptom and a test. It is a symptom of how cheaply a competent electric car can now be built when a single company controls its entire supply chain. It is a test of whether that achievement will be used to raise the floor of automotive safety in the developing world or to find a new lower floor at which it remains profitable to sell. The engineers who designed the car know what would be required to make every variant of it as safe as the safest variant. The regulators who approve the car know what they are approving and what they are choosing not to require. The families who buy the car know, mostly, only what they can see, which is a small, bright vehicle at a price that finally, after a long century of waiting, places private electric mobility within their reach. Whether that vehicle deserves the trust they place in it is not a question the car itself can answer. It is a question the rest of us, the people who write the rules and build the machines and tell the stories about them, are still in the process of deciding how seriously to take.